Okay, so as mentioned, you can also use the if function. So for the if function, so this is the command equal sign if F4 is this value. F4 is greater than or equal to. I considered the lower limits 81. It means I'll encode or the system will encode 5. And if it is greater than or equal to 61, it will encode 4 and so on. So this is the function. So let us just make this bigger. Okay, so this is the if functions that I consider. So F4 depends now on the location of the cell of your scores or the percent score in my data. And then all you need to do is just to drag it so that it will bring out or it will give you the performance. Or if not, instead of using the numbers, you can directly place a very poor, poor, good, very good, and excellent. Now, to come up now with the answer for the question, what is the performance of the students in the overall? So let us just consider the first one in overall. Of course, if you're going to answer also items for the performance, for instance, in algebra, geometry, and statistics, you also need to come up with the percent score for algebra. So in our formula for percent score of the overall, what we consider is the denominator is of course 30 because the total number of score is, or the perfect score is 30. However, for algebra, it would be equal to the scores here all over 10 multiplied by 100, and then you can again follow the same procedures just like what we did here. So now, if we are going to consider, for instance, the frequency or the answer for that question, how many of the students how many of them are very poor, poor, good, or very good, or excellence in their performance? So what we need to consider is the upper limits of this. So I'll encode that 20, 40, 60, 80, and 100. Next, you have to check if you have these options in your data, the data analysis. This is the data analysis. If you do not have this, you have first to add that in your Microsoft Excel. And to do that, you have to click File and locate Options and click Add-ins and then click Analysis Toolpack. Then Excel add-ins, you have to click this Go and then check Analysis Toolpack and Analysis Toolpack VBA. Click OK and it will be set here. So you can already see it here, of course, because I already placed or I added in my add-ins. Okay, next. Okay, so let's just recap. So our objective is to come up now with the frequency distribution table that will show the number of respondents with very poor, poor, good, very good, and excellent performance in mathematics. So what you need to do is to encode the upper limits of your range here 20, 40, 60, 80, 100. So again, it depends on your guide for interpretation. You cannot, of course, copy 20, 40, 60, 80, 100 if you are using a different scale for interpretation. So let us continue. So we have now 20, 40, 60, 80, and 100. So next, what I need to do is to click data analysis and then histogram. So of course, initially, you cannot find any numbers here once that it is your first time to open it. So for the input range, we will place the value of the performance. So this is the performance. So if I'll select the performance, okay, so I don't need to click the labels because I did not select the labels. So this is actually the performance. So let's do that again. So I use the percent score. And then the bin range now corresponds to this upper limits that I encoded. So what you need to do is to select this. And if you want to come up also with histogram, or rather with a chart output, then you can click chart output and click OK. So this is now our table. But of course, we know that the 20 here corresponds to, we can already edit this. This corresponds to 4. This corresponds, or rather, this is a very poor. This is 4. This is average. Sorry, it's good, very good, and excellent. Okay, so this is, and then we can change this to total, a total of 30. So this is the frequency. But what we need is the percent, so that it will also reflect now the distribution in terms of the percent. So let us compute for the percent. So we know that it's equal to 30. So we will just select this divided by 30 multiplied by 100. So the 30 here corresponds to the number of respondents. And then just drag it. So this is our percent, but let us edit this again into 2 decimal places. So again, to do that, all you need to do is just right click, format cells, and click number decimal places is 2. Then click OK. So this is now the level for simply performance. So what you need to do is to copy this and place now in. So I'll remove this now to place it here. So this is the answer for our question. What is the performance of the students in terms of the overall performance? So your task is, of course, to continue this by also answering how about the performance of the students in algebra, in geometry, and in the statistics if you want to do that. So in doing so, you can determine that the effect of blended learning maybe is higher or better in statistics than geometry or in algebra. Or you can also add problems like, so this is optional problems. Is there a significant difference between or among the, is there a significant difference between or among the performance of the students in the three areas of mathematics? So these are optional. And also optional problems, you can also ask, is there a significant difference between the performance of the students in mathematics when grouped by their profile variables, or when grouped by the respondents or students profile variables. Letter A, so it can be that the variable that you consider is, let's say, their learning style, or what else can possibly affect the performance in mathematics. It can also be their attitude and all other profile variables about your respondent. So again, the objective of answering the question, what is the performance of the students, because we made use of one-shot case study on the effect of blended learning. So what we really want to know is to the effect. So for us to determine the effect, then we need to get the performance, because it is the effect in the performance. And all other problems now, such as differences in between or among the performance in the three areas, and also significant difference between the performance of the students when grouped by the students' profile variables, are all optional. So aside from this, of course, we need to get the overall also by computing for the mean. So let's go back to our data. So how will we compute for the mean of the score? And also let's consider the standard deviation. So to do that, we will just encode equal sign average, open parenthesis, and then select this score, close parenthesis, then enter. Or, of course, here, okay, so this is the average of the students. So let us just correct. So actually, it's okay not to consider the score anymore. It is fine if you're going to consider the percent score. Anyway, the percent score is the basis for you to determine the level of performance. So the performance of the students, if the average is 65, it is very good. And also compute for the, so let us also compute for the standard deviation. So equal sign ST dev S, this one. Estimate the standard deviation based on a sample. So again, equal sign ST dev that S, open parenthesis, and then select this data again, close parenthesis, and enter. So if we want to know the decimal place here, because it's already rounded into 1, then we can set this back into, again, 2 decimal places. The value is 65.33. So let us place that also in our interpretation. So mean is equal to 65.33, which means it is very good. And with a standard deviation equal to 11.76. And of course, you have to arrange this end. You have to fix this in your chapter 4 of your paper. So this is just the answer for what is the performance of the students in the overall performance. So if you're going to place also the algebra, geometry, and statistics, then you can combine that in one table. Okay, so this is all for this video. Thank you for listening.